Now let's move back the CIST route into the MST region. I'm gonna lower the priority of the IST on switch 1. Spanning tree MST 0 priority, and let's make it 0. And now every switch should acknowledge switch 1 as the new CIST route. Do show spanning tree MST. The route is this switch for the CIST. And let's verify on switch 6, for example. Show spanning tree route 0C42, which is switch 1, is the route for each spanning tree instance with a priority of 0. If the CIST is within the MST domain, we can do load balancing between these two links, which connect the MST region with the PVST domain. So we have 4 active VLANs, actually 5, but let's say VLAN 1 is the native VLAN and it is not used. For example, let's say the traffic of VLAN 10 and 20 should be forwarded on this link, and the traffic belonging to VLAN 30 and 40 should be forwarded on this link. First, I'm gonna change the cost calculation in the PVST domain to use the long path cost method. In the MST region, the cost of the gigabit interfaces are 20,000 by default, but PVST Plus is using the short path cost method. See, the cost of gigabit interface is 4 by default. So we want that both domains use the same path cost calculation. So we change the path cost method on these 3 switches. So spanning tree, path cost method, and long, and we are going to issue the same command on the other 2 switches as well. And now gigabit interfaces have the cost of 20,000 on each switch. And let's see by default which ports are used for forwarding. On switch 2, port G02 is a boundary port and it's designated and forwarding. On switch 3, G02 is also a boundary port and it's also designated. And by the way, the role of this port G0/2 for the other instances, so for MST1 and MST2, is always the same as the role of instance 0, so in this case designated, because in this case the IST always determines the role of the other instances as well. And on the other side, on switch 4, show spanning tree, and because switch 2 is just simply replicating the BPDUs of VLAN 1 for every other active VLAN, the roles of each port is going to be the same as the role of VLAN 1. So in this case, root. So the port G0/2 is the root port of this switch. for every VLAN, and both G00 and G0/1 are designated. Again, not just for VLAN 1, for every VLAN. And that's what we are going to change shortly to do load balancing. But first, let's check the port roles on switch 5. And switch 5's root port is G0/2. The port G0/1 is a designated port, and G00 is an alternate port. So because of that, this link is effectively blocked in every VLAN. On switch 6, the root port is G00, and G01 is an alternate port. So this link is also blocked for every VLAN. So at this point, for every VLAN, the link between switch 2 and switch 4 is forwarding. Also, this link is forwarding, and the link between switch 4 and switch 6 is forwarding. And these links are blocking. So again, for every VLAN, because we haven't done any load balancing yet, now we would like to do some load balancing, and we want the traffic of VLAN 10 and 20 to use this link, and the traffic of VLAN 30 and 40 to use this link. So we want this link to be less preferable for VLAN 10 and 20. So we increase the cost of this interface G0/2 for VLAN 10 and 20. So on switch 5, interface G02 and spanning tree for VLAN 10 and 20 cost, and this should be higher than 40,000, because this link has a cost of 20,000 and this link has a cost of 20,000. That's 40,000, and this path is preferred, so switch 5, switch 4, switch 2, if this link has a cost of 40,001, for example. And let's verify. And the port G0/2 is now an alternate port for VLAN 10 and 20. So this link is now effectively blocked for VLAN 10 and 20. VLAN 30 and 40 are not affected. They are still using this link. The new root port for VLAN 10 and 20 should be G0/0. And that's right. And G0/1 should be still designated for every VLAN. Oh, let's check it. And on switch 4, we increase the cost of interface G0/2 for VLAN 30 and 40. Interface G02, spanning tree for VLAN 30 and 40, and the cost, again, we need anything higher than 40,000 to prefer this path through switch 5. So let's say 40,001, and let's verify. show spanning tree interface G0/2, and the root port for VLAN 10 and 20 is still G02, but for VLAN 30 and 40 the new root port should be G01. And G02 is an alternate port for VLAN 30 and 40, so this link is effectively blocked for VLAN 30 and 40. And let's do one more thing on switch 6. Let's do some optimization. So now this link between 6 and 5 is blocked for every VLAN, and we want to use this link between 6 and 5 for VLAN 30 and 40, so that this path through switch 5 can be used to reach the MST region. And similarly, for VLAN 10 and 20, we want to use this upper link. So to do that, I'm gonna simply increase the cost of this link for VLAN 30 and 40, so the lower link will be used. So interface G00, spanning tree for VLAN 3040, the cost, and this should be higher than 20,000 to prefer the other link. So 20,001, for example. So the root port for VLAN 10 and 20 is still G00, but for VLAN 30 and VLAN 40, the new root port is now G0/1. So to summarize what we have done so far, we have two separate STP trees, one for VLAN 10 and 20 and one for VLAN 30 and 40. This tree is used for VLAN 10 and 20, and this tree is used for VLAN 30 and 40. But let's verify that. I'm gonna create two separate SVIs on both switch 1 and switch 6 in two different VLANs, in VLAN 10 and in VLAN 40, for example. So show IP interface brief. Now we have two interfaces in two different VLANs. Let's find out the MAC addresses of these two interfaces. So show interface VLAN 10, and this is the MAC address of the interface VLAN 10. And show interface VLAN 40, and this is the MAC address of VLAN 40. So now I'm gonna do the same thing on switch 6, and I will ping the IP addresses of the same VLANs, and based on the MAC address tables, we will verify the port states of these switches. Now I'm gonna ping both SVIs of switch 1 from switch 6, and we will take a look at the MAC address tables. So ping 10.10.0.1, that's the SVI of VLAN 10, and ping 10 4001. That is the SVI of VLAN 40. And let's check the MAC address table. So the MAC address of VLAN 10 should be learned on G00. Let's verify. Show MAC address table dynamic. So the MAC address which belongs to VLAN 10, which ends with A, was learned on G00, and the MAC address for VLAN 40 ending with 28 was learned on G01. So from switch 6's point of view, everything is okay. And let's do the same thing on switch 4 and switch 5. So switch 4 should have learned the MAC address of VLAN 10 on G0/2. Which it has. And switch 4 should not know the address of VLAN 40, because the traffic of VLAN 40 is not using this path. So let's verify. And yes, this address wasn't learned on any interface. Similarly, on switch 5, the MAC address of VLAN 40 should be known on G0/2. And it is. And the MAC address of VLAN 10 wasn't learned on any interface. So let's verify that as well. And the MAC address table is empty. So as we have expected, we have two separate trees for 4 VLANs.